Hey everyone, today we're going to tackle one of the big ideas in object-oriented programming, polymorphism. Now I know, it's a word that sounds pretty complex, right? But trust me, it's actually the secret sauce that lets us write code that's super elegant, flexible, and honestly, just plain powerful. So let's demystify this thing together.
So, let me just start by asking you this. What if a single object in your code could act like a chameleon? Have multiple identities and just intelligently adapt its behavior depending on the situation? Well, that is the core idea behind polymorphism, and it's the key to building really smart, reusable programs.
All right, here's our game plan. We'll start with the main idea, what I call the power of many forms. Then we'll get into its two main flavors, compile time and runtime. We're going to look at some real code for both, and then we'll wrap it all up with a final scorecard so you can see the key differences at a glance. Let's do it.
Okay, first things first, the power of many forms. Before we even touch a line of code, we really need to get a handle on the what and the why of this whole concept.
The best part is that the word itself kind of gives the game away. Polymorphism comes from two Greek words, poly, which means many, and morphism, which means forms or behaviors. So you just smash them together, and what do you get? Many forms. It's really that simple. It's the idea that one thing can act in many different ways.
And here is the perfect real-world example. You. Seriously, think about it. You're one person, right? But at home, you play one role. At the office, you're someone else. And when you're with your friends, you have a totally different vibe. You're still you, but your behavior changes based on the context. That is exactly how polymorphism works inside our code.
Okay, so we've got the what down. Now let's dig into the how. In Java, polymorphism really breaks down into two main types. And the single biggest difference between them is when the program decides which behavior it's going to use.
So on one side, you've got compile time polymorphism. People also call this early binding. And just like the name says, the decision about which behavior to use is locked in early, right when your code is being compiled. Then on the other side, you have runtime polymorphism, or late binding. With this one, the decision is made way later, on the fly, while the program is actually running. The key thing to always ask is the choice made early or is it made late?
All right, so let's zoom in on that first type, the early decision maker. This is our compile time polymorphism, and the way we make this happen in Java is with something called method overloading. So you might be wondering, how does the compiler know which method to pick ahead of time? Well, it's all about what we call the method signature. And that's just a fancy way of saying the combination of the method's name plus the number and types of its parameters. As long as those signatures are different, the compiler can easily tell them apart and make its choice before the program even runs.
Let's look at some code to make this crystal clear. Here we've got a simple calculator class. Now notice, there are two methods and they're both named add. But look closer. The first add method takes 2 numbers and the second one takes 3. Because their parameter lists are different, meaning their signatures are different, the compiler has zero confusion about which one you want to call. And that, my friends, is method overloading.
Okay, so let's flip the coin and look at the other side, the late decision maker. This is runtime polymorphism, and we achieve this in Java through method overriding.
Now this is where things get really dynamic. Instead of the compiler making the call way up front, the actual decision is put off until the program is up and running. It might not sound like a huge deal, but this is what lets us write code that is incredibly flexible, code that can handle unexpected things, or work with objects when we don't even know their exact type yet. It's pretty cool.
So check out this classic inheritance situation. We have a parent class A and a child class B. Now notice that both of them have a method called show, and the signature is exactly the same. So, which one gets called? Well, that decision is made at runtime. If your program is working with an object of type B, then Java knows to call the show method from class B. It overrides the parent's version. That's method override.
Whew, okay. We've covered both types. So let's bring it all home with a final scorecard. This is a fantastic slide to screenshot for your notes, because it really locks in the differences. Okay, let's just run through this real quick. On the left, we've got method overloading. Remember, that's compile time, it uses early binding, and it's all about having different parameters inside the same class. On the right, method overriding. That's your runtime, late binding, and it happens between a parent and child class. Seriously, this table is your go-to cheat sheet for polymorphism.
So there you have it, the two faces of polymorphism. But it kind of leaves us with this one really fascinating question, doesn't it? How in the world does the Java virtual machine, the engine that runs everything, actually handle that late binding? How does it make that split-second choice while your program is running? Well, that's a deeper topic for another day. But understanding that, that's where you find the real magic that makes modern software so incredibly powerful.